you doing?
I'm doing great. How are you doing?
Doing good. Doing very good.
Good.
Things are
How
busy.
was your weekend? Yeah, no,
Uh,
understood. How was your weekend?
it was good. What did I do? I don't remember what I did.
Yeah.
I relaxed. I worked. Uh, it was good. Had sled riding with my 8-year-old son, so it was a lot of fun. How about you?
Oh, excellent. Yeah, quiet, upper Midwest. There's some snow on the ground, so we just sat around and we were pretty much domestic the entire weekend, but that's
Nice.
okay. I kind of prefer it that way.
Yeah, yeah, especially on the weekend.
Yeah.
Cool.
Yeah.
So you've got some stuff to show. I see some stuff here on the screen. What do you want to go over?
Yeah, so what we're going to talk about today is using an edge device to create a work order in your computerized maintenance management system. So we've been talking about the attributes that all of your IoT technology should have. Again, should be an open architecture, meaning that it plays well with others. You want to have something that's report by exception. So again, you only want to communicate if you have to. That communication should use a lightweight protocol because if you have 10 devices on a network, it's manageable. But when you have 1,000 devices, that's a whole different thing. So you want lightweight, and finally, you want everything edge driven. So this really is truly edge driven. Everything that's occurring here is going to happen from the edge. So we talked about, once you get into the various strategies around your maintenance and reliability, again, they always need to be technically feasible and economically viable. And oftentimes that means, especially for remote assets, you're getting into things that are, it's either going to, it's going to break. So, or there's going to be some kind of preventive maintenance on there. So every so often you're going to go out to the asset and do some work on it. Well, this is sort of the next strategy up the hierarchy, if you will. We're going to do a condition-based maintenance. And so what I'm going to use is an Opto22, their Groove Rio. So that's designed to do remote IO. And we're going to monitor a vibration sensor on this compressor. That's the example that I have here. And that's going to give us a 4 to 20, so an analog input. And then we're also going to monitor a discrete input through the filter that's on an air compressor as well. So there's an after filter, and eventually it does get plugged, and you're going to have to go in and change it. So we're going to create a work order based on the high vibration as well as one on a high pressure drum on it as well.
I'm going to back up and just make sure I understand. So this is for the guys and gals out there in SMRP, Society for Maintenance Reliability Professionals. So it's those people that would potentially want to implement a solution where you're able to monitor certain conditions of a device, vibration or pressure or something else. And then based on the status of those vibrations, once it reaches a certain limit, then at that point, you're going to show us how this tool works such that you can capture those limits, capture that data, and then automatically generate a work order in a CMMS system, maintenance system.
Absolutely.
Right?
That's exactly what we're doing. And
cool.
Again, I'm only using a single input. You can actually do multivariable. So when you start getting into more of the complex condition-based maintenance, you can look for several conditions that can be programmed in. But we're going to keep it simple. That works better for me when I do it that way anyway. So,
sure. And the other point I should point out too, to clarify, you had mentioned, and I think might be worth mentioning again, the criteria for what I think of as this open technology kind of approach, where we're not doing anything proprietary here. It's using the best tools to fit the situation. So can you go over the criterion again?
So as the 4 that I mentioned earlier, it's the open architecture. So again, that just means it plays well with others. So I'm using protocols and standards that are going to be readily available. So any other device or system that's connecting in here, it's going to be able to. They're going to work together.
Cool.
The next thing is a lightweight communication. So again, it's something that does not use a lot of bandwidth. And then it's also a report by exception, meaning that it only communicates when there's something out there. It's not like when you're on the family vacation and your kids keep asking, are we there yet? Are we there yet? Are we there yet? It's just 10 minutes away from grandma's house. It's kids, get your shoes on. We're about to grandma's. And that's the only thing that needs to get said, right? And then finally, it's edge driven. And that means that you want to have as much information coming from the edge in order to make a lot of these decisions. In this particular case, you're actually making the decision from the edge as well.
Perfect. Awesome. Great review. Thank you.
And again, it's I'm using a compressor. It can be any asset, and it doesn't even have to be a remote. It's just something that when you want to bring in your network and have something that's automatically driven. So
All right.
I mentioned earlier, we're going to use an Opto22. They have their Groove Rio. That's actually the landing page we are working on right now. We're going to use their built-in Node-RED. And what Node-RED is, it's just a flow program based on Node.js that you can use to do all kinds of it's a workflow for lack of a better word, and I even call it a flow. And then we're going to create a work order into the UpKeep maintenance management system. And we're going to take advantage of the UpKeep APIs and use their REST APIs in order to do that. So, make sense?
Makes sense. This is awesome.
All right.
Cool. Let's see it.
Cool. So, first thing to do, let's go ahead and get into the Groove Rio itself. And I see I've not called this the right thing. It's actually going to be, oh wait, no, that is the right thing. Sorry, my bad. This is the pressure switch. So you want to go in and edit that. So again, it's just a switch input coming right off of your the Groove Rio itself. And then that's all you need to do to set this up. So go ahead and hit save. And you can see that you have a state, you have an on latch, and you have an off latch. So I'll go ahead and pretend that differential pressure switch on that filter is high. So you can see when I simulate that, the state goes to on, and the on latch also comes on. And then of course, when I release that, then the off latch comes on. We're actually going to use the on latch to generate our work order. And the reason why is that if all of a sudden I'm getting near pressure where it keeps turning on and turning off and turning on and turning off, well, now you're going to continue to generate multiple work orders for that. That's something you want to avoid. So we'll go ahead and clear those because that's going to be our trigger. Then we'll also have the vibration sensor. Again, this is going to be that 4 to 20 milliamp signal coming out of there. So within the Rio itself, it's actually a 0 to 20 milliamp analog input. And then we've used some scaling of 4 to 20. And we've also done calibration. It's pretty easy to do. It's just a 2-point calibration where you put in the low point and you record it, high point, 20 milliamp, and you go from there. So go ahead and click save. And I'm using this little loop simulator. This is from TW Controls, so a big shout out to those guys. And when I just increase the current on there, you can see that my value of the channel itself changes as well. So I'll go ahead and put that back down. So that's all we need to do in terms of the channel configuration. In order to work with Node-RED, you do need to get a user API. So go into your accounts and your users. I've cleverly named mine David. And of course, you need to grab this API key. That's what you're going to use within the Node-RED itself. So go ahead and copy that. And we'll just go ahead and back out of here. And then from there, now we're going to go ahead and get into Node-RED. So that's either done via coming into the page itself and opening the Node-RED editor. You can actually get in here just by typing in the URL and then doing a / Node-RED, and that'll bring you into it. So before you can start drawing all of these flows in here, which I've already created, you do need to go into the menu itself and you get on a manage palette. And this is where you want to type in your your groove. And that's actually going to bring in a couple of palettes that you need to go ahead and get into your system itself. So just type in groove, it'll bring up these two, and then you're just going to want to install it. Of course, I've already installed it. And then when you come down here to take a look at all the palettes you can work on, you notice that one of them now is this Opto22. And these are all the various configurations you can use to create your flows. And just looking through here, there's actually a ton of things you can do. There's a whole dashboard palette. You can send emails, you can write to storage, you can do all kinds of parsing. I mean, there's just a lot of things you can do within the Node-RED itself. It even supports MQTT. So I've done quite a few things there. So before we start creating these, we do need to understand from UpKeep exactly how to use their APIs. And Ryan Chan at UpKeep has done a phenomenal job. He shot a video here using a Postman application to demonstrate how you utilize the APIs on here. And then of course, all your instructions are right here as well. So if you notice here, the first thing we need to do is we need to get authentication in there. So we need to use our email and our password, and then we're going to get the session token back. So in order to do that, I've created this flow here that's going to start with a timestamp. And what that does is it injects a payload. We're actually going to start this flow. So that's pretty simple. And then we put in the get token, the payload, or the session token payload itself. So you see, I've just written, it tells us this is on the header of it. It's a content type. It's a JSON file that I'm going to send. And the actual message payload itself uses my email and password. And for those that are scoring at home, just so you know, my password is no longer strong password. I've changed it. It's now stronger password.
All right, I'll go check it out. Thank you.
Yeah, right. That's stronger password. So go ahead and we'll cancel out here. So now once we've defined that payload, now we need to use the HTTP request. That's one of the palettes down here. And now what we're going to do, we're going to use a post. This is the URL that we would need to get to. And we'll go ahead and just click cancel and back out of here. And then finally, we're going to write over here just to, this is our debug module, but this is where we're actually going to get that payload back in order so we can create the rest of these. So I'll go ahead and hit timestamp. And you can see we now had success. And we now have the session tokens come back. And so when you're doing this, it's a good idea to go ahead and copy this information over here. So I'll put in the session token. This is from another time I did this. And we'll just go ahead and click done. And then now if we somehow manage to lose this date over here on that right column, we'll now be able to recreate all of our session tokens. So make sense what we've done so far?
Yes, I was on mute. Yes, it does. So some of this in eventual solutions for a standard solution you'd put in place, some of this would be a little bit more automated, but this, based on this kind of what you're showing now, is a great demo. This is a really good.
It's designed to be very simple, so it's understandable what it is we're trying to do. So now that we have our session token back, we want to start creating some work orders. So again, coming back to this work order API, you can actually just come right down here to work orders, and it'll tell you all the information you need to put in to create a work order. Really, the only thing you need is a header. Really, anything else is that's optional, but it wouldn't make a lot of sense if you didn't have like the title of it, description, and those types of things. And then when it comes back, this is actually the payload that you'll get coming back to your system. So coming back to Node-RED, let's go ahead. And this is where we're going to first start getting into the Opto22 itself. So now we're going to create a pressure switch. So this is going to be the device that we're going to monitor. So because this is running on the same local host or the same device, we'll use a local host. I mentioned earlier how we were going to use that the digital input on latch. So that's going to be the channel that we're watching for, the data type. And that channel index was 0. Opto22 uses a 0 indexed. So the first channel on there is actually at 0. And we just have it's a filter pressure switch is what we're working for there. I'll go ahead and connect that over. And now we're going to want to create our work order payload. So the first thing you need to do, of course, is your header. And this is where you put in your, you tell it that it's an application JSON. And then you need to bring in your session token that we got. And since that's changed, let's make sure that's all the same thing. So it is. So we'll go ahead and click done. Next thing we need to do is create the actual payload itself. So again, going back to the UpKeep and all the information you can throw in from the API, I've created all this. It's just a complete JSON string. So it's replaced the filter on compressed air system. We're going to go confirm it, give it a priority. I've already assigned an asset and a location and a user and an estimated duration, and of course, what kind of category this is. So I'll go ahead and click done there. And then the last thing I've done is in order to create a dynamic pay, I've put in, or excuse me, a dynamic date time. I've used the due date, I've just added in, and I've taken advantage of a lot of the built-in functions that exists. So within Node-RED, all the time is based on January 1st, 1970 at midnight. So this is just the number of milliseconds that has elapsed. And then I give ourselves 2 days in order to get this done. So 2 days represented in milliseconds is actually 172,000. That's the number of seconds in 2 days. One, we need it in milliseconds. So I put in that 1,000 just to multiply it through. So that's how we get a dynamic day in terms of the due date there. So then I take advantage of the work orders. Again, it's a post. There's the URL address for doing it. And then I'm going to bring it into our message payload here, over into our debug, just so we can see exactly what that looks like. So since I've done that programming, we're going to hit deploy. And we should be all ready to go. So now I'm going to simulate the pressure switch. Now is at a high point. So I'm going to hit the button. And now you can see it brings back the payload, brings back true. It says replace filter. So we can see, yep, everything is all good. And now we're actually going to go over into our CMMS. So this is in UpKeep itself. We're going to come to our landing page, and I'm just going to refresh this. And now you can see that I've created a work order. It's due in 2 days. Work order number 19. Its status is open. Replace the filter. It's low. Of course, it's assigned to me and the location name, their compressor, and all the things that go along with that. Pretty sweet, huh?
That is really cool. That's really cool.
So again, what we did there was just had to monitor that switch. Just create input, create a payload, create the API through an HTTP request. Then, of course, we just view that payload coming back. So let's take a look at what it would be on an analog input. So now we're going to check for vibration. This is a 4 to 20 milliamp. So again, still on the same device. That's a local host. It's an analog channel value. The channel index we had, again, is on channel 2, which is index is 1. And the node name is just, we're going to check for vibration. So typically in these type of instances, if you get a high vibration, that's when the technician is going to go out with his manual or her manual vibration instrument and go out and verify, yeah, there's a problem with the compressor on there. So that's what we're simulating here. So I'll go ahead and connect that over. But instead of looking for a switch location, we actually have to see a value. And I've set it to where now we need to have an 18 milliamp input coming into this channel in order for us to continue on with the payload. So it's going to check to see if this condition is true. So that's what this particular block is doing. And then again, we're going to do something very similar to the discrete payload. We're going to put in the message headers. Again, I just need to replace this session token. And so we get the right one in there. I'll go ahead and click done. We create the message payload, which again, it's high vibration, compression, the compressor vibration level is high. And then you want to confirm with a manual reading. Again, it's all the asset location, user, hours, those types of things. So that's all the same. And then finally, message, the payload for the actual due date itself. And we're dynamically through the function, giving it 2 days to get it done. So we're all done with that. Now we'll go ahead and create the work order. It's just a post. It's the exact same URL. And we're going to connect it into our debug node. So we'll go ahead and hit deploy. And then we'll go ahead and I'll use the handy dandy loop simulator that we talked about. Oops, bring that over a little bit. And I'll keep scrolling until we get up to 18. I think it makes more sense when you can see what's actually happening here. And then I think we have a success of true here shortly. There we go. So then it just popped in.
Nice. I saw that. Cool.
So we'll go ahead and bring it down. And you can see over here, there's the payload itself. Results true, high vibration, all the things that look like it's, created several of these, so I need to work on that. But so now you can see it created that, it brought it back as true. So we'll come over here to the work orders itself. We will, and it looks like we have a couple of high vibration here. So again, created that, again, the work order number, high vibration, priority, location, air compressor. This one got recreated because when I deployed this solution again, that switch was still on. I should have switched that off, but that's why you have multiples in here. And because once I got to 18 and 19, it kept creating a new one. So anyway, a couple of work orders in here. System's not exactly perfect, but I think you get the idea of what it is we're doing. So
yeah,
go ahead.
absolutely. So
down.
I'm going to try to, I took some notes while you were doing this to see if I got this right, and please correct me if I'm wrong. So Opto22 PLC as one of the tools, Node-RED and Uptime for the CMMS. And what was that device you were holding up as well?
Oh, yeah, this is just a little loop simulator. So there's Tim over at TW Controls. He does all kinds of PLC YouTube videos, and he does sell some devices for troubleshooting and simulating and those types of things. So nice. He has one for loops. He has one for PLCs as well. So cool. just some really cool, because when you try to find a loop simulator, I mean, this thing was like $100, pretty inexpensive for what it does. Otherwise, you're into these super expensive, was it Fluke instruments? They're going to set you back, a pretty penny. So yeah, that's what that was. Yeah, and and the CMMS is UpKeep. So I've been very, very generous in allowing me to use the APIs in order to create the simulation. So normally you have to have an enterprise subscription to do it. So
All right, then I'm going to go over some of the details, some at mid-level, let's call it, to make sure that I understand. So then on the Opto22, you have Groove, which is kind of like a configuration, or I'll call it an operating system because of my background in software. And then Node-RED is operating on that PLC as well, I think.
Yeah,
Right?
it's just a remote I/O. So all you're doing is putting all kinds of different channels out there.
Fair.
So you can,
Okay, so then you're setting up the Opto22, then setting up setting up the channels, and then you're going into Node-RED, grabbing the palettes, and then building out the steps to first get the session token with uptime, and then you are putting together these sequences of various palettes to first generate a work order for pressure, and then another one to generate a work order for vibration. And you were setting each of those up, running them, and then they were effectively creating the work order, pushing that whole payload that you had created, the JSON payload, to UpKeep, and then you saw the work orders.
Yep.
Is that
That's
good
pretty
summary?
much what happens. Yeah, no, you covered it.
Sweet, this is awesome.
And where this gets really cool is, of course, we're doing that on the entire device. There's no reason why you couldn't actually take the same scenario and have a bunch of different edge devices out there doing something very similar with Node-RED, now monitoring all those. So within Node-RED, I can actually take this, I can export this flow, and you can export it to a, hang on a second here. You can actually export it to a file, or you can export it to a, you can just copy it to the clipboard. And so I have another Node-RED instance running on my network. And so where you want to see it get really cool is now I can import, paste that entire flow. Now I have this exact same flow over here on a completely different instance of Node-RED. And the only thing I need to do in order to make this work is actually, I'm no longer on localhost. I need to go right to the IP address of the actual Opto22 Groove Rio, hit done, and deploy. Come over here to my debug. One thing I'll point out, if you want to do this, you will need to generate an API key for that system. There's a little more configuration you need to do than just a copy and paste, but it's pretty easy. But once again, I can come in here. I can now trip the pressure switch, and you can see I've now generated a completely new work order. I'll run up my current. And now you can see I've created that payload again. So we'll go right back over here to UpKeep. Now you can see with a completely different instance of Node-RED,
just by increasing the current, you've tripped it.
Just by automatically. Yeah, just by copying and pasting. So got a little bit of noise in here as you deploy things, but you get the point of it. It's very flexible. A lot of different things you can do. It doesn't have to be on a compressor, but the upside is that you are now able to remotely monitor an asset, create some rules around condition-based maintenance, and automatically generate a work order within an computerized maintenance management system. And you can do that all from one little device.
And you've already answered one of my questions, which is like, then what can you do with it? And you've already talked about it, which is scaling. Yeah. Scaling the solution.
It's very scalable, because again, I can have multiple. If you look at what I'm monitoring, if I have multiple Rios or any other device that does integrate with Node-RED, and there's actually quite a few of them out there, you can create these rules. I can say, no, I'll show you another flow that I have. I've done this before, but I can now just monitor channel states. I have all kinds of rules I can put in. I can run this into I can run this into an MQTT. So if I want to put out an MQTT payload, if I want to put this into like a MySQL server, I have that ability. I can actually send myself an email. So I've set up conditions where I can actually watch for these function changes, and I can actually email myself, because what somebody suggested is, rather than automatically creating a work order, I can just have it email me, hey, there's a problem, and then I can verify that, yep, there's a problem. Let's go out and do something. So a lot of different options you can do with it, but that's really more of a Node-RED thing. But Again, the Groov Rio supports that Node-RED interface.
Dave, would you consider Node-RED a production level system? 'Cause I know a lot of people, even some of our developers, have become familiar with Node-RED through Raspberry Pi, and Raspberry Pi itself, great for pilot projects, but not something you want to put into rugged industrial environments.
Yeah, it's certainly not on shutdown system or safety critical, and even in process control, it's not quite ready there. I would say code assist is something that is ready for it, but I don't think it'll be very long before there'll be a fairly good level of acceptance around using Node-RED for, especially instances like this. It's not security or it's not safety related. How about that?
Yeah, that makes sense. Good. Wow, this is really awesome stuff. This is great. Thank you. I really appreciate it. Is there anything else you think worth covering?
No, I think we've done it. I've talked a little bit about MQTT. Again, when you set everything up, the Groov does support that as well, so I can actually send that out and create all of that data payload is now captured within my, or however I want to utilize that. So I can now subscribe to that information and know that the state of this changed and it could trigger something else in there as well. So a lot of different options.
So we'll, for this video, we might come up with a few other notes, a couple other ideas I have just to create a little text outline of what we've talked about here. We'll put that in the notes of the video, and anybody interested for when this video gets up on YouTube, feel free to subscribe, and we'll be talking more. I'm looking forward to the next video.
Yeah, we'll do. And I'll send you a copy of that, the JSON payload, so you can actually put that up there on YouTube as well. Of course, I'll change to the session ID and the username and the password. So other than that, at least give you an idea of what you can do.
You'll change the password to strongest password at that point?
Yes. It's going to go to strongest password. Ah, dang it, I gave it away again.
Thank you, sir. Have a good one.
Okay, thanks, guys.